12.4. We're looking at limits at infinity. And so when we graph usually rational functions, it's when we have horizontal asymptotes. So as we go closer and closer, bigger numbers, right? So get closer and closer to infinity, which we really can't reach. But as we get bigger and bigger x's to plug in, what happens to our function? What happens to our y value? So when we have fractions, rational functions, and we have, as this gets bigger and bigger and bigger, and we're just dividing by some number, then it goes to infinity. If the top is just some number and the bottom keeps on growing and growing and growing, then it's going to get closer to 0. So this is like 1 over x. So as x gets bigger and bigger, this is gonna approach, get closer and closer to 0 as the limit gets bigger and bigger and bigger. And then this one would be something like, x squared minus 1 over x, something like this. So this one's going to get bigger and bigger and bigger and bigger and bigger as well. So that's going to go to infinity as my x's get bigger and bigger and bigger. So something like that, or even just plain x squared over 2 or some number like that. Okay, and then the same is true as just putting a negative, right? So if there's say a negative out here on this one, that would go towards negative infinity. If there's a negative here, then this would still be going to 0. Right, so there's the limit as x gets bigger and bigger and bigger, or bigger negative, I guess you can say, what happens at those situations. Okay, so now you might be asking, well, how do you take the limit as x goes to infinity? Well, as x gets bigger and bigger and bigger, what we can do is, one way is just to divide. You can divide everything by the largest exponent of the denominator, so that means I would divide everything by x squared, right? Which is basically what I taught you in pre-cal too. Usually you do this when you might have a more difficult problem, but for the most basic kind of thing, as long as the degree of the denominator is the same as the degree of the numerator, then you can just really take the lead coefficients 3 over 5. So this will go to 3 over 5. You can divide everything by x squared because that's the largest exponent on bottom, which would look something like this. So see how I divided everything by x squared. So basically what happens here, because we have this going to infinity, this going to infinity, this is going to be just 1 over x, which will go as the x goes to infinity. These will each go to 0 as I take the limit. These will go to 0, this will go to 0. These change to just 1, these change just 1, so that's how I get just 3 over 5. Just sometimes on the more complicated ones, especially with negative exponents, you might want to do this way, divide everything by that. But for all intents, whatever. For most cases, you're just going to look at the degree of the numerator and the degree of the denominator. And whenever they're the same, then this would be a 3. Whenever they would be the same, then it would just be the lead coefficient of the numerator divided by the lead coefficient of the denominator. Anytime the denominator is bigger, like this one, whenever the denominator has a larger x, then it's always going to go to 0. If the numerator has a larger x, then it's going to go to infinity. So this means right here that I have a horizontal asymptote at y equals 3/5. So when I graph these rational functions, I'm going to have at 3/5. So say this is 1, so this is 3/5. I'm going to have a horizontal asymptote. Whenever the denominator has the larger degree, then it's going to go to 0. So then I would have a horizontal asymptote at y equals 0. When the numerator is bigger, so if I get an x squared over some number, and I'm graphing that, then it's going to be a oblique asymptote. And what I have to do there is a little tricky. I actually literally have to actually divide it out. In most cases, you have to do long division to figure out what that line is, that linear equation is. So here at bottom here, this is more complicated one because you have to retype these as the square root of. Right, so I have the square root of the top and the square root of the bottom, which is a half power. All right, so I can rewrite this as 12x cubed minus 5x plus 2 all over 1 plus 4 x squared, x squared plus 3x cubed. And they're both being square rooted, so that means they're both raised to a half. Now I can go ahead and distribute that. Oh, I can't distribute that half power. But what I can do is I could simplify the insides and just look for, so I could divide everything by x cubed, which these are gonna, the limit would take this to 0, would take this to 0, take this to 0, take this to 0. So basically I would get left with this. These are both being raised to the half power, or square root. This would cancel. 12 divided by 3 is 4. 4 to the half power is 2. So my answer would be 2. Okay, so you could go ahead and pause the video and go ahead and try this. So this is a more complicated one, so you'd have to divide everything by x. But because the top is being square rooted, you're going to have to divide the top by square root of x squared, right? So in reality, I'm dividing everything by x, but x is the same thing as square root of x squared. So inside of here, I want to divide both of these by x squared. And it's still being square rooted, but the bottom I'm dividing by x, because x and x squared being square rooted is the same thing. So now as the limit, as you take the limit of this, because my x is getting bigger and bigger, this is going to go to 0. This will go to 0. These will cancel. I get square root of 2 over 3. So I get this answer. So the only thing we have to watch out for here is because we're taking x squared and square rooting it, that leaves a possibility of both plus and minus. So this would be our answer if x is a positive. So if x is greater than 0. And then for the next one, if x is less than 0, then square root of x, we would need to take the absolute value of that, which is just negative x, right? So if my x is negative, then I would times it by a negative, which would make it positive, okay? So then when I divide here, I'm going to divide by a negative square root of x squared, which just leads to a negative, which leads to a negative, which leads to a negative root 2. So you really have two answers. When x is greater than 0, we have root 2 over 2. No, root 2 over 3, sorry. And if it's negative, then it's negative root 2 over 2. Root 2, again, over 3. Negative. This will be 3. Okay, so, for example, like, why I have to do this is because if I plug in negative numbers, say negative 3, I would have to times that by a negative out front to make it positive in order to put it in. But if I'm putting a positive, that's just going to take the same number. Okay, so you can go ahead and if you want to, you can try these two. Go ahead and try them on your own. Again, you can just do it the short way. So pause the video, try it yourself. Okay, so if you just look at these two, this one's bigger, so it's going to be some form of 1 over x, which is going to go to infinity. Sorry, meant 0, because as my x goes to infinity, as this goes, it gets bigger and bigger and bigger, this is going to go to 0. This one inside here, we have to divide by x to the 4th. This one we divide by x squared, because x to the 2nd is the same as the square root of x to the 4th. And because this is in the square root, we have to put it under x to the 4th. So we just have 1 over 1 plus 0. Square root of that, which is 1 over square root of 1, which is just 1. We look at this one. Multiply top and bottom by the conjugate. Plus x. On the bottom, same thing. FOIL the top, we get square root of x. Oh, that square root's gone. So we just get x squared plus 1 minus x squared. So that cancels out, and I just get 1 on top. And then on bottom, I have the square root of x squared plus 1 plus x. So I divide the inside, because that is being square rooted, x squared. That means I have to divide that by x squared, and the 1 by x squared, and then plus x. So as I plug in infinity, this is going to go to 0. This is going to cancel out to 1, so I just have x plus 1. So I have 1 over 1 plus x, and that's just going to go to that's just going to go to 0. So that will just, this thing will just go to 0. Okay, so here's something you can try. I'm not going to do it for you, so you're going to have to do it yourself. So try this one, same kind of thing as last time. So try that. Here's another one. You can try it yourself as well. You know, just make sure. You can cancel like factors if you can, or you can go ahead and multiply it out, which, again, we don't really care about all the extras. We just care about what is the largest x on top and what is the largest x on bottom. So if you were to multiply this out, what would be your largest x on top and what would be your largest x on bottom? But you don't actually have to do it. And then if you have x on top with a bigger x on bottom, that means it's going to go to 0. And if you have the bigger x on top and a smaller x on bottom, that means you're going to go to infinity. And if they're the same, that means it's going to go to the lead coefficients divided by each other. So go ahead and try it yourself. Okay, vertical asymptotes. A little bit different, but not too bad, because all I care about is the denominator and when the denominator is going to get me to 0. Right? So I just set the denominator equal to 0, and I just go ahead and solve for x's. We can see we can factor out an x squared. Then we can go ahead, set both of those equal to 0. That'd be 1 minus x squared. We can set both of those equal to 0, so that means x squared equals 0 twice. So it kind of has multiplicity there. So that means something's happened at the graph. And then here we also have x squared equals negative 1. Or sorry, positive 1. Square root both sides, and we get plus or minus 1. So those are all our x's, 0, plus or minus 1. Those are our vertical asymptotes. So then what we just need to do, for horizontal asymptotes, we do the same thing, largest over largest. So this would be 1 over negative 1, which equals negative 1. So it would be y equals negative 1. These would be our vertical asymptotes. This would be our horizontal. Okay, then you get a problem like this. This is where you just factor the top. If you need to, just define x-intercepts, I guess. But I'm going to have to factor the bottom, because I want to set this equal to 0, and then I'm going to factor the bottom. So I just need to factor the bottom. But you can see what your horizontal asymptote right at the beginning. These are the same. So it's going to be 1 over 2. So y equals 1 over 2 is the horizontal asymptote. So most of the time, those are the pretty easy ones. This one I'm just going to have to factor. Set equal to 0, find my vertical asymptotes. All right, so that's basically it for finding the limits at infinity.